Today I am explaining to you the working principle of a single phase induction motor. This is a single phase induction motor. This I am removing from a table pedestal fan. Everybody know that the construction of a single phase induction motor. This is the rotor of the induction motor and this is the stator of the induction motor, and there is stator, there is a slotted area, slotted laminated steel is there. Laminated steel is using for the reducing the eddy current loss. Now today I am going to explain to you how this single phase induction motor is working. Normally when you are learning the single phase induction motor and even three phase induction motor also, everybody know that once we are given a supply, there is a revolving magnetic field appear in this area. Actually this is not a revolving magnetic field, it is a properties of a sinusoidal wave, and we are shifting. If it is in three phase and in three RYB, three different phases there, because of these three different phase, that is RYB phase shifting is there, that is the reason there is a field is creating it. It is look like a revolving field, not a revolving field, it's look like a revolving field because of the sinusoidal wave. Now come to the point. Again I am coming back to the construction of the single phase induction motor. Here you can see the lot of wire is there. Actually this is two is for the capacitor, and this all for this phase main winding, and this separate winding is for taking the different speed. I will explain in the drawing. Actually if this is single phase induction motor, it is just like one starting winding, one main winding, and you are supplying a voltage here, and there is a rotor here. Okay, what are these two? These two terminals is for the capacitor. That capacitor is connecting to here. This one is connected to, another one is connected to here, and this common terminal, this is connected as a common terminal, this is connected as a common terminal, this point here, this point, this one is connected for one main winding, at the same it is connected for the capacitor, and there is a lot of tapping is taken here for different speed. Leave this one, this is just for the explanation. I am stay here. Okay, here there is a two winding is there, one is main winding, another one is starting winding, and this it is connected 90 degree electrical apart. Suppose this is the starting winding, this is the main winding, this is starting winding, this is this starting winding, this is main winding, this starting, like that only. And there is a rotor. What we can see, this rotor is just a corrugated like this. This is split type. Why it is making like this? Once the field is applied to the stator, if it is here stator, there is a magnetic field is created in this stator winding. It will be induced an EMF in this conductor, then in this rotor, this rotor will be create a rotating magnetic field. If even this will be shorted in the two side, it will be following somewhere else like this, because it is not the south. If it is flowing like this way. Now I will come back to the explanation of single phase induction motor. Before we will go, you know that one three phase induction motor will be working because of there is a three phases there, R, Y and B. This is 120 degree phase shift. Because of this, there is a field is created. One is just like this is R phase, and after 120 degree there is another phase, Y phase. After 120 degree there is another phase, B phase. This is the nature of, because of if it is in a rotor, there is a 3 winding, 1, 2, 3 winding, R, Y, B. Suppose R is high value, then Y and B is negative value, it's a low, different value. Next instant, next moment, what happened? B is in opposite that high value, this will be like that only it will be create a field here, because it is already a phase shifted value, because already sinusoidal wave, whatever the generated voltage in a 3-phase voltage, it is a 120 degree phase apart. Okay. Sorry. Anyway, before starting, I will tell you, we can consider this is the rotor. This is the rotor of a induction motor. I'll explain you. This is the rotor of induction motor, and this cage type. Actually, cage, just like a cage, is cage type induction motor is there. And I am here using a one winding. Only one winding I am showing. Instead of this whole winding, I am taking only one winding, and it is considered it is 180 degree electrical apart. 180 degree electrical apart. Okay, not 90, 180 degree electric. This is 0, then it is for 180. Okay, once suppose we applying a voltage here. We are going to apply voltage here. Here we are applying to voltage. This is a sinusoidal wave. Okay, then this is plus, this is minus. What if a current will move like this? A current will be move like this. This suppose a case IM, and it will pass through this one and it will come back IM. Okay. Normally what will happen, once I am taking only this portion, that is, this is the sinusoidal wave. This portion only I am taking first, this positive. Then automatically, according to thumb rule, if a current is flowing through this conductor, there is a field will be creating like this. Okay, there is a field will be created like this, and it will be in the direction this one, and it will be in the direction this one. Okay. What happened? This field will be induced in this rotor. This field will be induced in the rotor, induced in this rotor. That is induced an EMF in this rotor, because it is already, because there is a small air gap only between the rotor and stator. There is a field is generated here. This field will be induced an EMF in this rotor, because it is already shorter, then a rotating current will be created. Then what happened? There is a field is there. That field will be okay. According to Fleming's, there is a current, there is a EMF induced. That is, current will be rotating like this. Okay, suppose just like I am marking like this, rotating like this. Then what happened? If according to Fleming's left hand rule is motor and right hand rule for generator. Just for remember, L, M, left hand is motor rule. Alphabet L, after that it's motor. Then according to Lenz's law, if a current flowing this direction, a field will be induced in this direction. There will be a force is created in the upward direction. A current is in this direction, a field is coming like this, and a force will be coming like this. Is that? I am making this cross section here. This is the conductor. This is the conductor plus, and there is a field will be induced in this rotor. It will be induced. Then there is a rotating current. It will be like there is a rotating current will be here. Then a force will be created in this direction. A torque. We can say a torque. Similarly, here it is in this direction, and current will be opposite direction, then automatically torque will be in this direction. Okay, now you can see that once a current is passing through this conductor, there is a torque is created, this torque here, and definitely rotor will be move, because this is here, move little bit. But what has happened in the next moment, what will it will come to negative. That means Im will be in the opposite direction. Automatically torque will be in the downward direction. This is downward direction, then this will be upward direction. Okay, that means next one, this is positive half cycle. This is for the positive half cycle. Then negative half cycle, what happened? This will be in this direction, this will be in this direction. This is negative half cycle. Then what we can say, if suppose we are applying a voltage here, current is passing through this, first moment this will be rotated like this. Okay. First moment it will be rotated like this, second moment it will be rotated like this. That means it will be just like vibrating like this. That is means in a single phase transformer, if you are having single phase transformer, the transformer, single phase induction motor, there is no self-starting. It is not a self-starting. And how we can make it as a self-started motor? There is a lot of possible method is there. I will explain one by one, but here I am going to explain mainly for the capacitor split phase motor. Okay. Okay, then in working principle of single phase induction motor, that is fine. Okay, we can, what is that? We already say that there is no starting torque created in a single phase induction motor. Then how we can make it a single phase? There is a lot of, one method is split phase motor. Phase motor. Second one is shaded pole. Third one is a repulsion starting motor and a reluctance motor. Okay. Now what we are going to do, most of the single phase induction motor, they are adapting split phase induction motor. What is this split phase induction motor? From this concept I will explain to you what is a revolving magnetic field. What is a revolving magnetic field? I will come to this one. Now what we are going to do, I will come to this. This is initially we are taken, there is a current is moving in this direction, there is a main current and this will be written. Okay, I am going to explain again. This is happening in the positive half cycle. The next moment, that is, okay, this is starting winding, there is a current will be passing like this, main winding, and I am drawing one more diagram. This is main winding, this is starting winding and main winding, this is starting winding, this is rotor, and we are applying a voltage V here. There is a current I will pass through this one, and IM will be here, IES will be here. Okay, now what we are going to do, there is another option. What is the option? I want to make another voltage here immediately after this. Okay, I can do one thing. I will make another waveform here, this is current IM, this is current IS. What is in first instant? You know that first instant there is a field is creating like this, and on that time I am making this is a dead. This winding is dead. But when it is moving to the, before moving to the negative cycle, what I am going to do, I am giving another supply to this force, that is called as IS. This will be IS. Then what will happen, there is a force will be created like this. There is a field will be created again, force will be like this. Okay, same, this will be also, there is a, it will be created. Now once more I will clearly explain to you. This is stator, this is, here I am going to, this main winding, this is main winding for a positive end, and this is negative direction. There is a field, initially there is a field is creating like this, and here it is, a field is creating like this. This will be induced here, this will be induced here. Then a torque will be created like this, a torque will be created like this. Then additional winding, this additional winding I am providing here. See, when IM is maximum, this IS is 0. When IM is maximum, this will be 0. Next portion, when IS is maximum, IM is 0. That means next instant what is happen, when next instant what will be happen, this will be moved, and here there is a field is created, here there is a field is created, this will be in this direction, this will be in this direction. Okay, then what is happen, ultimately what is happen, now this is 0, this is maximum, this is maximum. Then what is happen, there is a torque will be created like this. That means when I am keeping the rotor in this first section, there is a force will be created here and here. Then next instant it will come to here, then again this is coming, this is alternately coming, automatically it will be rotated. This is the principle of magnetic field. That means if IM is maximum, this will be negative, then this will be maximum, this will be negative, this field will be moving like this. That means ultimately what is happen, this will be moving like this, maximum high, this will be moving high. Ultimately what happen, first here maximum, second here maximum, then again maximum, again. This process is called as revolving magnetic field. You see that one, if I am taking this winding, you can see lot of winding is there. First I am maximum, second first it is starting winding is maximum, initially minimum, then maximum, minimum, maximum. This will be lot of winding is we are already provided here. Then each and every it will be, force will be moving like this, torque will be moving like this. That means here maximum, negative, maximum, negative, maximum. That means this will be moving maximum, negative. This is maximum, negative, maximum, negative, maximum, negative, maximum, negative, maximum, negative. It is moving like this. This is called as revolving magnetic field in between the rotor and stator. Just like this, we can say that this is called as revolving magnetic because of this magnetic field. It is induced a magnetic current will be in the rotor. Because of the rotor, it is a rotating in nature. Why it is rotating? Because of this, it will be rotating in nature. Then what is happening? A force torque will be created, it's automatically rotating. Then how we can make a phase shift? I want to make a second phase. That's a shift I want to make. That is, normally there is a lot of method is there for split phasing. One is a resistance split phasing motor. Resistance. This is nothing. I can explain to you. Resistance split phase motor means there is a main winding is there, there is a starting winding is there. Main winding, we know that one. In winding there is an impedance value. Okay, there is an impedance value will be there. That means resistance plus jx. Resistance plus jx. Normally, while construction time, what will be main winding? Main winding, relatively low resistance. Main winding, relatively low resistance and high reactance. And this will be make high resistance and low reactance. X is low, R is high. Ultimately, what happens? The current moving through this one is high value of reactance. It is, if I am applying a voltage here, it is lags an angle of alpha. Okay, that main winding is reactive value is high, then that reactive angle will be, it is around 25 degree to 30 degree electrical, it will be shifted, and this is low reactance and high resistance. That means this phase shift is comparatively, because reactance value is less, comparatively less than that of Im, this will be less, that is which is gamma. Then ultimately total current is there, this is I will be flowing there. Then what happens? Once it is maximum, that means these two are maximum but in a different time shift. That means we will get an output wave. Suppose this is the Im, then there is a small phase shift will be happen because of this reactance value. Because of this reactance value, this phase shift will be get a small torque here, but relatively by using the resistance split phase motor, starting torque is very less comparatively to capacitance start motor. Then we can come to the capacitance start motor. What we are doing? We are providing a capacitor here. Simply, that is normally what we are using in house of purpose. There is a capacitance we will provide here. There is a main winding. Everybody know main winding. Suppose we applied a voltage here. The main winding voltage is here. Reference voltage vector is here. Main winding. This is maybe reactive, highly reactive. X high value. XL is high value. Then there is a phase shift there with voltage, that is, suppose this is alpha, but I am providing a capacitor here. What happened? You know that capacitor, whatever the current is passing through the capacitor, it will be lead the voltage by another angle, because here is the reactance is there, which is not perfectly 90 degree, because already reactance will be there in the starting winding and plus capacitor, it will be not low. There is an angle, it is less than 90 degree, maybe 40 degree. This is also less than 90 degree. That will be, there is a current Is leads the voltage by an angle gamma. Then resultant what will be happen? Resultant current will be vector sum of these two, but this angle is approximately 90 degree. Normally, what we are using this technology here, we are shifting 90 degree phase shift for main winding and starting winding. Main winding and starting winding, main winding and starting winding, we are provided as approximately 90 degree electrical. Okay, this technique normally we are using for all home appliances. Then normally this phase shift is when Im is maximum, Is will be not exactly, it will be get around 80 to 85 degree electrical. Okay friends, actually this is the working principle. Here one more thing, You must know I am here taking only two coil, one starting coil, one value. Here lot of windings are all together will be acted here. Then there is a not revolving field, high low, high low, high low, high low, high low, high low, high low. Just you remember like this: high low, high low, high low, high low, high. It's showing look like a revolving structure. That is called as revolving mind field, creating this one. And normally the books and teachers will be saying that these rotors try to catch this, whatever the field is creating is a synchronous speed. It will try to catch this field, but it is less than that field. There is a slip will be there. Leave it this. I am explaining only here how it is working. I hope this video is helpful for you to understand the working of a single phase induction motor, and this is the concept of the induction motor, how it is working. And if you are liking this video please like it and share your friends, and if you are not yet subscribed in my channel, please subscribe it, and let we can see you on the next topic. And if you have any suggestion for the topics, you can send me in the comment box. I can try to explain what is the concept. Mainly I am focusing about the concept, how, when there is no equation, how, when it is happened. This is the equation, and thank you. Have a nice day.